In the last videos, we talked about the work done by a constant force F. We said the work of F on the object equals to F times the displacement. Okay? If we want to draw this relation between F and dx, let's take fx. Okay, I take just one direction. We have the motion in terms of x-axis. We don't have a motion on the y-axis. Initially, the object was at the position x initial and the final point at x final. So between x initial and x final, we have a constant F applied on the object. So F is constant between these 2 points. In this case, as you see here, F at initial point equals to F at the final point. Okay? Here we have F. Now, the distance between x initial and x final, let's say this one, d, equals to x final minus x initial. Okay, and you know x final minus x d equals to x final minus x initial equals to the displacement. Okay, so we can say the distance here equals to the displacement equals to x final minus x initial. So F times dx, F times dx equals to the area of this rectangle. So we can take as a general notation here the work done on the object equals to the area end of the curve. It's very important relation between we can use a geometrical calculation to calculate the work. Okay, F times the height times the length. So we can this relation between f dx is just in the case if f is constant. Let's take another case if f is not constant. If f is not constant, we cannot use this relation between f and dx. So initially we have f, and f is not constant between the initial and the final state. Okay, so we can say also the work done between these 2 points equals to the area end of the curve. To calculate the area end of the curve, okay, we have to do some application. You have to you have to cut this area to many small portion, and you do the integral. Okay, I don't want to explain in details the calculation of the area. We can say in general the work done here equals to the integral of f times dx. This is the general relation and between the x initial and x final. Okay, so we get finally the area. Okay, if you want to understand what I mean by dx, I can explain. To apply this relation, f must be constant. Let's have a small portion of this area. The distance here equals to dx. It's a small portion of x. Okay, and here we have f, the height equals to f. So the area of this small portion here, we get only a small displacement, so we have a small work, d omega equals to f, which is constant at this distance between these 2 points. F is constant, okay, equals to f dot dx. Okay, if you want to calculate the total area, we have to do the integration between these 2 points, between x initial and x final. We get finally omega equals to f dx between x initial and x final. Listen, we don't need to do any to calculate in details this relation. What you have to know is just this relation. In the case of a variable value of f, okay, we can write in general, if f is constant, omega equals to f times the displacement. If for a varying force, omega equals to f dx, okay, between x initial and x final. Just remember these two relations in the case of a constant f and in the case of a variable value of f.